Okay, so today we're going to take a look at relationships and what it actually means when we say that these numbers have a relationship or, a linear relationship. What does that actually mean? So today we're going to kind of take a look at that in a little bit more detail just so that you can actually see the pattern that this creates when we have a linear relationship. So these types of problems, in these types of problems, there's going to be a clear pattern of either some kind of growth or decay. So something is growing, literally, like if I'm saving money, my bank account's growing. If I'm growing a plant, the plant is growing. Or decay, that could be I'm spending money, or something along those lines. That's usually more like where we're looking at decay for right now. There's also, radioactive decay, but we're not going to get too much into that yet. That's a little bit more advanced math. So first, we're going to identify our starting point. So what do we start with? What are we growing from or decaying from? And then second, we're going to identify the change or the pattern. So what are we either growing by or changing by each period? So it could be per day, it could be per week, per month, whatever we're growing by per. And it doesn't actually have to be time. It can be some other item that's the kind of the term there that we're growing by. So this will either be an increase, we're either adding it, or a decrease, which is subtraction, right, from the starting point. So let's go ahead and read this problem. A plant is already 54 centimeters tall, and it will grow 1 centimeter every month. Let h be the plant's height in centimeters after m months. Write an equation relating h to m. Then use this equation to find the plant's height after 12 months. All right, so first, what are we given? What do we know about this problem? Well, if we kind of go back and we read that very first sentence, that's most of the problem, actually. A plant is already 54 centimeters tall. It will grow 1 centimeter every month. So if we think about that, we can picture that in our heads. I can picture a plant, whatever plant I'm picturing, and it's so tall already. It's 54 centimeters tall, which, that's not super duper tall, but it's going to grow 1 centimeter every single month. So we're given that the plant is 54 centimeters tall and it grows 1 centimeter every month. So we have the information we need. I have my starting point. I know where it is right now, and I know what it's going to change by per month in this case. So now I'm going to scooch down so we can see the rest of this page here. So let's use the facts to establish a pattern. So after 1 month, the plant's height will be h equals 54. This is my starting point plus my change, right? It's changing 1 centimeter because it's only 1 month. So I have 55 centimeters. After 2 months, the plant's height will be 54 plus 2. And again, with this one, the pattern is matching the month because it would be 1 centimeter per month. So 1 month would be 1 centimeter. 1 centimeter for 2 months is going to be 2 centimeters. So this one matches a little bit more because our change is 1. So sometimes this change isn't always going to match exactly the number, the term number that you're going with there. So after 3 months, we have the height plant will be 54 plus 3 because 3 times 1 is 3. So we have 57. After 4 months, the plant's height will be 54 plus 4 because, again, 4 months times 1 centimeter for each month. So we have 58 centimeters. So we definitely have a pattern here. So therefore, after m months, so if I have m months, I don't know if it's 1, 2, 3, or 4, I'm just going m, the plant's height will be 54 plus m, because I can see that here. Here's my variable. 54 staying exactly the same each time. The output is different each time because the variable, the number month I'm putting in is different. So this is my variable. So remember, this is the starting point plus the change per month. And if the change per month were more, if it weren't 1, then remember this would not just be 1, 2, 3, 4 because we'd actually have to multiply these. But since it's only 1 per month, it matches the number of months you're in. So to find the plant's height after 12 months, because that was actually the second part of the question there, was after 12 months, how tall will the plant be? We're going to use m equals 12 in this equation that we just wrote right here. So this was the equation. So after 12 months, the plant's height will be 54 plus 12 months, and there's 1 centimeter per month. So we're just going to add 66 centimeters. All right, so I think we're going to look at another one of these guys. So we're going to go, Chris needs to read 2 novels each month. Let n be the number of novels Chris needs to read in m months. write an equation relating n to m, then use this equation to find the number of novels Chris needs to read in 13 months. So again, I've put it out here. I want us to identify the starting point and the change. So we also need to identify our variables. We need to make sure we understand we're not just using x and y right now. They told us that he needs to let n be the number of novels. So the number of novels is going to be n, and m is going to be the number of months. So make sure you're using the correct variable, because Alex will mark you wrong if you don't use that correct variable that they've already told you to use. If they haven't told you which variables to use, you get to choose. That usually means it's not going to be part of your actual answer you type in. But if they tell you which variables to use, you have to use those ones. So we have n and m. So now we're going to look at our starting point. Well, if he's just starting off, he needs to read 2 novels each month. They didn't tell us that he's read anything yet. So we're kind of thinking he's starting right now. So 0. He's starting at 0 books. He hasn't started reading yet. So he needs to start reading 2 novels each month starting right now. And so the change is going to be 2 books per month. So every single month, he's going to be reading 2 books. So this one is going to be a little different. And I put this on here because the number of months is m, and he's reading 2 per month. So it's really going to be 2m, right? So we can kind of reduce that very quickly so that we can start writing an equation for this. So with this one, we have the number of novels that he's read equals 2 times the number of months he's been reading. So this is not going to match the number of months like the last one did, because it was 1 centimeter per month for that plant. This is going to be 2 per month. So it's going to be twice. If we're in month number 1, he's read 2 books. If we're in month number 2, he's read 4 books, right? So the pattern will be slightly different on this one, but it still follows a very strict pattern. Basically, whatever the month is, we're multiplying by 2. So now I'm going to take this third question, or the second question. This is the one that we're going to type in. They also have you type in the equation on this one. So you type in the equation, and then you go through and you answer the second question. So we're going to find the number of novels Chris needs to read in 13 months. So number of novels is going to equal 2 books per month, and he's been reading for 13 months, so we're just going to multiply. 26 books in 13 months. And you wouldn't type in the books in 13 months, you'd only type in the 26. I believe books will already be there for you. They're not going to have you type in words like that, because Alex doesn't want to have to grade anything that may be spelt wrong or anything like that. So they don't tend to have you type in words. But all right, so that was examining relationships when we look at linear word problems. I hope that helped, and I will see you in the next video.